Question 8, part A. An arithmetic progression is such that its first term is 6 and its 10th term is 19.5. Find the sum of the first 100 terms of this AP. A is given as 6, and then the 10th term, which is going to be A plus 9D, is equal to 19.5. So I can use these two to find the value of the common difference. So 9D is going to be equal to 19.5. Remember, A is 6. So if I take the 6 this other side, it will be a minus. And then D is going to be equal to, this one will be 13.5. Then divide by 9. Okay? And 13.5 is the same as 9, then plus 4.5. So when I say 9, this one will give me a 1, then plus this one will be a half, 0.5. So that will be 3 over 2. Okay, simplify to 3 over 2 or 1.5. Now we know that sum of the first n terms of an AP is n over 2 into 2a, then plus n minus 1d. So meaning n is 100, so sum of the first 100 terms will be 100 over 2 into 2 times our a is 6, then plus, of course, 100 minus 1, that will be 99, then times 3 over 2. So, of course, this one will give us 50. Then inside here we have 12. And then what do we have here? 99 times 1.5. That one gives us 148.5. 148.5. When I add the 12 and then I multiply by 50, what do I get? Plus 12, then times 50. That is 80.25. So the answer here is 80.25. Then part B, a geometric progression A1, A2, A3 is such that A1 is 24. That's the first term. And then the common ratio is a half. The sum to infinity of this geometric progression is denoted by S. The sum to infinity of this geometric progression is denoted by S. The sum to infinity of the even numbered terms A2, A4, A6 is denoted by SE. Find the values of S and SE. Okay. Now we are going to have A1, which is equal to 24. Okay. Then A2 is going to be equal to 12. Because remember, the nth term of a GP is A, then R power n minus 1. Okay? So, if it is the third term, then you have 3 minus 2 here, then you have AR squared. So, you just multiply all through by R. So, to get the second term, I'll get the first term, then times the common ratio. So, 24 times a half, you get the 12. And then now the third term, that is A3, is going to be this one here times a half, which gives us 12. Then A4 will be 12, oh sorry, pardon me here, this one is 6 here. Then A4 is going to be now 3, then A5 times a half, that one is going to be 3 over 2. Then A6, maybe I will stop here. We shall have this one times a half, 3 over 2 times a half, that will be 3 over 4. Okay. Now we know that sum to infinity is equal to A over 1 minus R. Okay. So S is going to be equal to, that is for the whole of it. Okay. That is the one which was given here. So the first term is 24 out of 1, then minus a half. So this one will give us 24 over 1 minus a half, you get a half. This one will somersault and then multiplies with that. We shall have that as 48. So that is the value of S. Now, let us look at this other one for the even. Okay? They are saying that the even numbered terms, A2, A3, and that is equal to, we are seeing the sum to infinity as SE. So the first term for this kind of sequence is going to be A2, okay, which is 12. Then the next one is F4, which is 3. The next one is going to be S6, which is 3 over 4. Then the common ratio is going to be, I can get the 3, then divide by the 12. This one will give me a quarter. Or I can get this one, divide by 3. You still get a quarter. So in here, now the first term has changed. It is 12. And then the common ratio is a quarter. So SE, the sum to infinity of those even numbered terms, is going to be A, which is 12, then divide by 1 minus, this is a quarter. So we shall have 12, then divide by 3 over 4. The 4 will come up here and then multiplies with the 12. Then that one will give us 48. Then divide by 3. That one will give us 16. So that means SE is equal to 16. That is that.